Hi, I'm JD, and what we're going to be doing today is just basically learning the precise definition of a limit. So you have the limit f of x as x approaches a equals L, which is some number we have no clue. As you know, a limit, you have x approaches a, so you're getting closer and closer to this number on the y-axis. You're approaching the x from both directions. That's what you're starting with. You're starting with the x's. So you're actually starting with a, and you're getting closer and closer to that point from both directions. Now as you approach it, you're going to be a certain distance away. And that distance, you can say, is delta as it relates to the x's. So here, this would be a minus delta, and this would be a plus delta. And so as it approaches, as x approaches a from both sides, it's going to approach some y. That some y is L. And so it forms like a little box. But what you have here is a certain range, and let's label that range epsilon. So this is L plus epsilon, and this is L minus epsilon. Because that's the range. You're approaching at some epsilon is greater than 0, because epsilon is in reference to distance. Distance is always positive when you neglect the direction. And same thing with delta. So those are both greater than 0. So you have two ranges. You're starting with the x's. So if x, and remember we're dealing with distance, so you deal with absolute value of delta, then 0 is greater than the absolute value of f of x minus L is less than epsilon. And know this, that a cannot equal, that you cannot have x equaling a by definition of a limit. So what do you have to do to prove precisely, the limit? You have to use what's called a delta epsilon proof. You have to start with this. You're given this information, this right here. Then you have to prove this. And that's it.